Hello everyone, this is Mrs. Lopez and this is lesson 3 in our 8th grade in module 1, numbers in exponential notation, form raised to a power. Before we get to all these difficult looking things, x to the m to the nth equals x to the nth mth, I would like to give you an example of numbers before you get to understand all of that. So far, we've learned that if you multiply numbers with the same base but different exponents, and it works only for multiplying numbers with the same base, you will get to add the exponents, right? So for example, 2 to the third times 2 to the fifth equals 2 to the power 3 plus 5. We are not multiplying the bases, it stays the same. It's just we are counting how many 2's we have here. So here we have 3 times 2 multiplied by itself. Here we have 5 times 2 multiplied by itself. So together it's 8 times 2 multiplied by itself. We also learned when we divide numbers written in the same base and different exponents, we are going to subtract the exponents. For example, 15 to the power of 8 divided by 15 to the 6th power. 15 stays the same. It means I am multiplying 15 by itself 8 times. And here I'm multiplying 15 by itself 6 times. But because it's a division problem, we can simplify those 15s that have the same number of exponent, and what is left is 15 to the power of 8 minus 6, which is 15 to the 2nd power. So in algebraic terms, when we have x times x to the power of a times x to the power of b is the same as x to the power of a plus b. And for division, if I have x to the power of a divided by the x to the power of b, I'm subtracting the powers, x to the power of a minus b. These are the two rules that we know. We also know that if x is used by itself, it is x to the 1st power. We just don't write the 1st power because we see how many x's I have. I have 1x, and so x multiplied by itself once. There is nothing else in there. So for example, if you have number 2 written by itself, it means the same thing as if I wrote 2 to the 1st power. Okay? So now we have a new rule. We have a rule that if I have two numbers, let's say 2 to the 3rd power, and that whole thing together to the 6th power, how can I rewrite that in exponential notation? So let's imagine that 2 to the 3rd power. What is it? So 2 to the 3rd power is 2 times 2 times 2, taken by itself 3 times. Now, that is what I have in parentheses, 2 to the 3rd. Now, the whole thing has to be written by itself, multiplied by itself 6 times. So I'm multiplying that by itself, 2 times 2 times 2, and again 2 times 2 times 2, and again 2 times 2 times 2, and again 2 times 2 times 2. How many do I have? 5, and one more, 2 times 2 times 2. Okay, so now that is taken together 6 times. Okay, so I have how many 2's? 1, 2, 3, 4, 5, 6, 9, 12, 15, 18. I have 18 2's multiplied by itself. So that is 2 to the power of 18. do we have any relationship between these two powers? Do you see any relationship between 3 and 6 and 18? Yes, we can actually multiply 3 by 6 and that will equal 18. So when we have a number raised to the power and that is again raised to another power, we just need to multiply the exponents. So you will have 2 to the third to the sixth equals 2 to the power of 3 times 6 now, and that is 2 to the 18th. Now let's look at our rule. X to the mth to the nth is the same as x to the nth mth. That doesn't mean that the two letters are just written next to each other. What do we call the operation when we have two letters standing next to each other? It's multiplication. It's the same as n times m. Okay? And that is the explanation. X to the mth is x multiplied by itself m times, and the whole thing is taken by itself n times. So we are counting how many x's we have right now, and that is multiplication. Okay? So let's look at some more examples here. Let's have, before you get started, just random numbers. Let's say 7 to the second to the sixth. And that is 7 to the second multiplied by 6. And that is going to be 7 to the 12th. We can write it out if you want, and I can do 7 times 7, and then again 7 times 7, just like in twos, and then again 7 times 7, all of these 6 times, and then count all those, and it will be 12, just like in that example with the twos I showed you. Okay? All right, so let's continue here in exercise 1. We have 15 to the third to the ninth, which is going to be 15 to the power of 3 times 9, and that is 15 to the 27th power. Next one, exercise 2, negative 2 to the power of 5 times 8. This is a power raised to the power. We are not multiplying just like we did before. This is a power raised to another power. That's why we are multiplying. And that is negative 2 to the power of 40. Exercise 3. 3 4/10 to the power of 17 times 4. And that is going to be 3 4/10 to the 68th power. Exercise 4. Now we have an S. It's the same as the previous one. Any number we can substitute instead of the S. So we work with just a variable. S to the power of 17 times 4. And that is S to the 68th power. Okay? Sarah wrote, exercise 5. Sarah wrote 3 to the power of 5 to the power of 7 is 3 to the 12th. Correct her mistake. Let's see, what is her mistake? She added the exponents, but we are not multiplying numbers with the same base, different exponents. We are raising exponent to the power, which is a little bit different than just multiplying those numbers. Since we are raising it to the power, we need to multiply the exponents. So we can write down that Sarah added the exponents instead of multiplying them. Instead of multiplying them. 3 to the 5th to the 7th equals 3 to the 5th times 7, and that is 3 to 35th power. Okay, we're going to skip exercise 6. We don't need that right now. And move along to the next one. Okay, so now let's take a look at just a little bit slightly different rule here. Xy to the nth power is x to the nth, y to the nth. So how does that work? Let's take a example using numbers. So I'll take a different paper here. Okay, so if I have, let's say 4 times 6 to the power of 2. A small number is easier to work with. Okay, so let's look at our rule. X and y are two different numbers, and we are raising them to the power. We have two different numbers raised to the power. So we can multiply 4 by 6 and then raise it to the second power. So let's try to do that. 4 times 6 is 24. To the second power is 24 times 24. 24 times 24 is going to be, and I will show you on the calculator how to do it easier. You probably know it, you might not know it yet. So 24, and I'm going to raise it, this little button that says raise to the power of 2. And you can create any power there. You can do 6, you can do 3, any power works. And then you click on enter, and that is 576. For the squaring, you can also use a different button. You can do 24 and squared, x squared right here. And then click enter, and you will get the same one. But that raise to the power button, it can raise to any power. It can be power of 3 and 4 and 5, all those. Okay, so 576. 576. Okay, so now let's see if that will work using our rule. I can take 4 and raise it to the second power, and I can multiply it by 6 raised to the second power. Let's see what happens. 4 to the second power is 4 times 4. 6 to the second power is 6 times 6. So you will get 16 times 36. Let's take a calculator and multiply. 16 times 36 equals 576. 576. So that works as well. So instead of writing that out, because we will have not only numbers, with the numbers working very easy, we can just multiply them and raise to the power. Sometimes you will see something like this, 4a to the 6th power, for example. We will not be able to multiply 4 by a. That's the highest we can go here. We can't do anything further. But what I can do, I can take and multiply 4 and raise 4 to the 6th power, and I can take a and raise it to the 6th power as well. That'll be the same thing as I would do these ones right here, or this one right here. So I can, if there is a multiplication inside, I can raise any of these factors to the same power that is outside the parentheses. Okay? That's what it means right here. X to the y to the nth power. X times y to the nth power is x to the nth times y to the nth. We can write it out this way. Let's see. The way they are explaining it here is a little bit different, and I will show you that as well, how they show it in Eureka. So if we have 4 times 6 to the second power, I'll do it like that. I can write 4 times 6 multiplied by itself 2 times. 4 times 6. So this is 2 times, right? 2 times. By knowing commutative property of multiplication, which we learned really in 6th grade and 7th grade, we can combine the 4s and the 6th. 4 times 4 times 6 times 6. And that is 4 to the second times 6 to the second. That's how they explain it in Eureka. You can also do it this way, 4 to the second, 6 to the second. It works either way. Okay, so this is just a different way to prove it. All right, so let's take a look at exercise 7. 11 times 4 to the 9th. Yes, of course, I can do 11 times 4, but we are learning it using our rules of exponents. So we are going to do 11 to the 9th times 4 to the 9th. And that will also work as well. I can do 11 times 4, which is 44 to the 9th power. It's going to give us the same exact answer as if I would raise 11 to the 9th and multiply by 4 to the 9th. And right now, I don't even need the answer. I just care about the process. I need to know how to take out parentheses out of this equation. Okay? Let's take a look at this one, next one, exercise 8. Here it's different because I have a number raised to the power and I have another number raised to the power, and the whole thing is raised to the power. Okay, so 3 to the second to the 5th times 7 to the 4th to the 5th. And using the product rule that we just learned earlier, I can actually multiply power raised to the power. I can multiply these powers, and I will get 3 to the 10th times 7 to the 20th. 3 to the 10th times 7 to the 20th. Let me just turn on the lights. It just went off. Here we go. All right, so exercise 9. Now it's different because exactly as I told you earlier, we have letters and numbers, variables and constants. So I have 3 to the second times 8 to the 4th, and the whole thing is raised to the 5th power. So what am I going to do is to multiply 3 to the second, and I'm going to bring it to the power of 5, multiplied by 8 to the 4th, risen to the power of 5 as well. Now I'm going to get rid of these parentheses and using power rule. So I'm going to multiply the powers. 3 to the power of 2 times 5 times a to the power of 4 times 5, and I will get 3 to the power of 10, a to the power of 20. Exercise 10. We have 5x to the 7th. 5 to the 7th power, x to the 7th power. Why do I write it this way? Because 5 is also to the first power, and x is also to the first power. So if I multiply the exponents, I would do 1 times 7, which is also 7. Okay? Moving on, 5 to the first power times 7th power. If that works for you, write it out. Times x to the first power times 7th power, and y to the second power times 7th power. So we have 5 to the 7th power, x to the 7th power, and y to the 14th. Exercise 12. Here we have only letters, and this is the case where just multiplying them by itself is definitely not going to work. So I'm going to take a to the second power risen to the 4th power, b to the first one risen to the 4th power, and c to the 3rd power risen to the 4th power. And I'm going to multiply those exponents. A to the 8th, b to the 4th, c to the 12th. And that's it. There is nothing else we can do to simplify it even further. Okay? Now we have another rule. Again, here I have now division. I noticed that a lot of you are trying to multiply or add the exponents when you see a division problem. You cannot do that. We add the exponents only when we multiply numbers with the same base. When we divide numbers with the same base, we have to subtract the exponents. So here I have a division problem and raised to the nth power. And how does it relate to x to the nth and y to the nth? Let's look at the first one. If we look up here, here we see x to the nth multiplied by y to the nth. So they're taking each factor inside the parentheses and raising it to the power that was outside the parentheses. Here I have a division problem. X over y to the nth power is the same thing as x to the nth over y to the nth. And I can do it the other way around. I'm sorry, you can't see it. X to the nth over y to the nth when we have like this. And that is the same thing as x over y to the nth power. Let's look at example before we do this. Let's take, let's see. Let's take 1/2 to the 8th power. It means that I will have to multiply 1/2 by itself 8 times. 4, 5, 6, 7, 8. This is multiplied by itself 8 times. When I multiply 1 by itself 8 times, it's still going to be 1, but it's also 1 multiplied by itself 8 times. So it can be 1 to the 8th power over 2 to the 8th power because I have 8 of the 2's as well. So 1/2 to the 8th power is 1 to the 8th power over 2 to the 8th power. I cannot simplify them any further because these are different bases. If I had the same base, I would be able to simplify. But I have different bases, so I just leave it as it is. Okay, let's look at exercise 14. We have 4/5 to the 3rd power, and I need to relate that rule to this one. So I will have 4 to the 3rd power over 5 to the 3rd power. That's all. And then when I have exercise 15, I have the opposite. I already have 8 to the 10th over 9 to the 10th. All I can do is to put it in the parentheses 8/9 and then take the whole fraction into the 10th power. Okay? All right, so this is lesson 3. Your homework is the problem set, and the problem set looks like this. We are going to take these and numbers in parentheses and put them into the power as well. So just thing for you to remember, when we have a number raised to the power which is raised to another power, we are multiplying the exponents. And when we have a division problem, when we have a fraction or a 2 divided by 3, is the same as I'm taking the 2 and raising it to the power and taking the 3 and raising it to the power. That's all you need to know from this lesson 3, and I will see you in class.